Welcome to episode 2 of Fintech Foundry, where we explore unfiltered perspectives from the front lines of fintech, senior leaders, engineers, marketers, and salespeople, and more. My name is Reddy, and I'm your host. Today, we're talking to Mourad and Adrian Ionica from Nine Spokes. Mourad is the head of engineering, and Adrian is the tech lead for the architectural team here at Nine Spokes. In this conversation today, we talk about the challenges, triumphs, learnings, and insights from rebuilding a fintech platform. To give you a little perspective about the NiceBooks platform, the goal for it is to put SMBs at the heart of financial services. It's built for them to do their business management in one tab. Businesses can connect their business apps, like their accounting software or the POS software, that they use to ensure they're on top of their KPIs to make informed business moves. The platform is also available as a white label solution for financial institutions to offer to their customers. Without any further ado, let's dive into this conversation with Mourad and Adrian on how to rebuild a fintech platform.
So, morning, Adrian, Mourad. Let's kick off. Let's get straight into the meaty conversation our audience has been dying to listen to. So first off, I understand that at Nine Spokes, there was a lot of effort expended by the both of you and kind of the wider team around rebuilding the platform. And so I was wondering if you could share a bit of insight into that whole story and that whole process with the audience today.
Yeah, certainly. So Adrian's been in the company a bit longer than I, so he's been there in the early days. We had the initial what we call the V1 platform, which at some point became too difficult to maintain. So I had a lot of technical debt in it, and onboarding new tenants and any kind of feature improvements took way too long. And that was just the tip of the iceberg. When we started digging into it, we realized that scalability was never taken into account in the V1 platform. So what that meant is it was always going to be a bottleneck in terms of how many customers we can service subsequently at any given point. So Vesper was new, I was new, and we had a kind of a look under the covers, and at some point it became evident that we probably did need to do some major overhauling. And so the conversations began just to get an idea of effort and what that would look like. And ultimately what we wanted to do, in addition to moving it to a public cloud service, because it was locally hosted in a data center, we also wanted to build something that's cloud native, so able to harness all the features of a cloud native application, something that is scalable automatically, and many other features, as well as having something that's a bit more modern and takes into account customer and scale. So the other aspect was security as well, so we had to really emphasize security quite a bit. So that was sort of the catalyst that led us to having to think about rebuilding the whole thing.
That's awesome. Adrian, do you have any thoughts or any bets that you were particularly grieved by when you kind of were working with that platform?
No, I think so. I think Mourad covered everything really nicely. I would probably just add that when I arrived, everything was everything was Java, and that was good for me because I was familiar with the Java language, and then everything started to change gradually, and just the amount of transformations that the platform has gone through ever since I joined has been amazing. And for a developer like myself, it's just it's just amazing to go through all these changes and the learnings that you get from it, and just seeing how everything works so much better now. And
it's been an uphill battle though. I have to admit, a lot of the early adopters were against the rebuild, so there was a lot of different reasons why not to do it. One of which was obviously that there was many months of effort that goes into something that was unproven. There was the fact that we had a production platform and we had to maintain that while trying to change the tires on the bus while the bus is driving around. On top of that, we had to kind of make a strong case for we're using a new language. We're using Go, and it was not really very popular at the time, so not a lot of people knew about it. And Java was well established. It was the king of microservices. But the way it was implemented, the architecture was very monolithic, and it was ancient. Let's put it that way. So it wasn't implemented the right way. And in hindsight, if it was done from correctly from the ground up, Java is perfectly fine for the job, although it is very memory and resource intensive, and that doesn't play well with our strategy of having to have something really lightweight and cloud native. So as a result, one thing led to another. We just give it a try, and then eventually we sort of had an initial MVP, and then from there it just materialized.
Yeah, just going back from the transition from Java to Go, I think like when I said, it was everyone was familiar with Java and they were happy with it. But once we transitioned to Go, I think everyone came on board, and we all found out how nice it is to write, and how much it's more direct, less verbose than Java, less resource intensive, and I think more suitable for a cloud architecture like we have.
It was designed for that. I mean, it's a Google language, and they specifically designed it to scale, and it was very lean. I'll probably get into that a bit later, but ultimately, we didn't have too many choices. I mean, we assessed a couple of languages, one of which was Node.js. I think the company started with Node.js before going to Java. Seriously considered JavaScript and TypeScript or other variants. I think the reason we ended up not doing that was more of the same. It's difficult to maintain very large scale applications written that. Not that I have anything with it. In fact, we did have many Node.js services at the beginning. It's just that once we get the hang of Go really well, it made more and more sense to kind of stay on that lean path, and so do away with some of these, a lot of the bloat that we didn't necessarily need. So.
No, that's awesome to hear. One point I wanted to dig a little deeper on is just in terms of trying to convince the team, the wider team, to make that transition from Java to Go and kind of go into that, because I imagine that's something that a lot of people would inevitably go through, right? Just at the pace of at which technology is accelerating at the moment. So I was wondering if you could kind of paint a picture on how exactly you were able to kind of convince the team, whether it was a struggle or maybe it wasn't, and kind of what you guys did to help ease that along.
Sure, yeah. It was case by case basis. Some individuals are always keen to learn, pick up new things, new skills. Those individuals were naturally very inclined to pick up Go. They were very curious when we mentioned it. We shared some samples, how that might work. They adopted it. Adrian is one of the other those individuals. On the flip side, there's people who are slow and steady. They know Java really well. They have committed to becoming to be Java developers for life, and that kind of didn't resonate too well with them. So whilst there was some similarities, they're both compiled languages. They are kind of derived from C in a way. So it was easy for competent Java developers to pick up the language. Many of them didn't want to make that journey, and so they ended up dropping off halfway through. So yeah, it's everybody's different. I think it came down to the personality and the level of the attitude, right?
I think someone said, I can't remember who, someone from Ninespokes, that a developer is not, you're not a Java developer or a JS developer. You're a developer, and you should apply the same concepts no matter what the language.
Yeah.
And I guess at the core, the values that are the same, and your goals are the same, right? So you want to write efficient code, fewer bugs, easy to maintain. The language is just the last aspect of it. So
Exactly.
Go is like what I said, it is similar in a way to Java. No, maybe.
Syntax, maybe, yeah. It's based on different principles, but certainly
it's based, yeah. So it does take a while to wrap your hand around Go. I think is the object-oriented part of it, because everything is object-oriented these days, and Go kind of steps steps away. It's a step away from that, but
yeah.
Once you get used to it, you find that you can do everything you want. And yeah, for me especially, it was it was a very welcome change when I joined Ninespokes. I have only been working with Java, and I came from a company that was building financial software, so it was kind of dull. I don't want to say anything bad about them. I'm not going to mention their names, but it was kind of dull, right? It was stuff that was done in-house. It was you were kind of losing touch with what the latest technology was out there. And when I arrived to Nine Spokes, it was Java, which was good for me because I had something familiar to work with. But then I really welcome the fact that we implemented services in JavaScript to start with. I really wanted to get into that, and we did that. So we had pure JavaScript services, and then we had GraphQL, and then we shifted to Go, which is it just I think just for a developer, for someone that loves doing this, it's Nine Spokes is just an amazing place to be. Yeah.
Definitely a golden opportunity. A lot of people really appreciate the ability to get their hands dirty with something new. It is a skill that you pick up, and it teaches you to write very lean code. Always take into consideration other people reading your code. So a lot of the other languages allow you to be very creative, very artistic. You can write things in 1,000 different ways. It's whatever you feel like a particular day, until someone else goes to read that and then they're wondering what that's all about. It's just, that's how it is. That's what makes developers happy, is to be able to get creative in their code and say, shrink it down to one line perhaps. So it was quite the opposite. It's very opinionated. It's very prescriptive. You can only do things a certain way. And while that takes away some of the creativity, learning curve is very flat. So anybody looking at your code who has never seen it before is able to follow through with minimal knowledge. That's what the language designer wanted, the ability to create something that is easy to adopt, and they certainly did that. But really, the main reason we went with that language, to be completely honest, is more runtime. So we wanted to create something that I keep saying scales well, but something that starts easily. So we had our V1 stack running in containers in the early days, and it was a resource hog. So it took a lot of memory, and it became evident that while some of these Spring Boot services were container friendly, it took a lot of resources, and the cost was going to skyrocket. So Go took a very different approach. The size of the containers were under 10 megs, which is incredible. The startup time is very, very quick. It's under a second. And the compile time for anybody using Java is also under a second on a normal machine. So that creates a tremendous productivity boost where you get to see results immediately. Whatever you write, you can compile it, test it instantly. And when you run it in production, you scale in under a second, which is also amazing. So those are some of the attractive aspects that we want to take into account. Not to mention, as I mentioned earlier, that it is a cloud native language, indicating that it has all the tools necessary to support concurrency really well and anything that you want to do at scale. So that's some of the things that you normally have to be a bit more careful with some of the other languages that they do well in small environments. But again, when you look in a hyperscale, it's much more difficult to take into account. So yeah, that was some of the reasoning there.
No, very insightful. Thank you for digging in on that. I suppose a next natural step would be to look at some of the other design considerations that you guys thought about when building out the platform. So we talked about kind of speed and kind of adaptability at scale. What about in terms of security? What were kind of the thoughts around that and decisions you guys made with that?
Arguably, that's probably one of the biggest important factors as well, mostly because of our clients. So we deal with banks. And banks will not hold back when it comes to penetration testing and security testing. And so the idea was, how can we build something that is guaranteed to pass all the scrutiny that tests that the banks will throw at us? And so that took a lot of work. I'm gonna say it took a lot of work to be able to come up with a design pattern that is repeatable, that is guaranteed to be passing in all the tick box. Otherwise, we'll be spending a tremendous amount of time continuously remediating whatever they find, and it just becomes a total resource hog. So yeah, so security from the ground up, that was one of the luxuries we had when you rebuild a platform from the top down, is the ability to say at every aspect of the way, how can we incorporate security? One of which is developers do it every day, so writing code with security in mind. The build pipelines, the test pipelines, the automation done immediately after that. is very security conscious. So we scan containers, we scan the code, multiple layers. We do static code analysis, all the standard practices. We do OWASP scans on it. And once that's done, the way we deploy it as well, so the way the entire environment is deployed is also very much security centric. And we've got, in addition to that, some runtime tools that we use to be able to detect intruders and things like that. So a lot of these things couldn't be done easily on the V1 platform, so we had to really take that into account going forward. So yeah, much on that, Adrian? Or
yeah, no, I think I don't have anything to add to this. Yeah, you're the expert on this matter. We're just yeah.
No, that's awesome to hear. So it seems like the platform is kind of up and running in a state that you guys are happy with. How do you deal with kind of new requirements that come in? So if someone has a bright idea from somewhere in the business, and how do you guys think about integrating and I suppose evaluating that in terms of the current platform and moving forward, keeping all those things that you've chatted about in mind?
yeah, so I guess with a new platform, we had to come up with a new process as well to ensure that whatever was built from day one is honored. What we do is, Adrian and I do several types of reviews throughout the life cycle of a feature. So at the very beginning, when a product owner proposes a new feature in the product council, what we do is we do a rudimentary assessment to make sure that what they're asking for is feasible. It's something that's not far-fetched, and in most cases, they tend to come up with things that's quite creative and not necessarily bad. So we'll just give it a quick tick mark there to make sure that it's suitable and achievable. And then from there onwards, they get into writing features and stories. That's what kind of we dive into a bit more detail. And at that stage, we do the thorough tech review. So Adrian is probably the guru at that. He could probably elaborate a bit on that. The idea was to be able to dive into the detail, into explaining exactly how this is going to be implemented, knowing what you know about the platform. So taking a high-level product idea and sort of breaking it down and say, here's exactly the elements that are being modified to support this. So having a holistic view across the whole platform and say, X, Y, Z will be touched and modified using this exact method to be able to support that feature. And then the final stage will be to have a team review. So the team themselves, when they pick up the work, their technical leads will go into even more nitty-gritty detail and kind of decide at a very precise level how that's done. And all of that is tied together using a standard kind of pull request review process, where some of us get the ability to validate and kind of make sure what was done is according to our standards. So 3 different tiers from from coarse grain all the way down to fine grain. We get involved across the whole thing, but Adrian does the majority of the grunt work in that space.
Yeah, and I would add also the code review layer at the end. Obviously, there's a lot of work happening, and we cannot cover. You cannot go over each pull request that gets created, but the vast majority of them are being reviewed by one of us, and during that stage we you get one last chance of saying whether the implementation matches the design, and it meets all the security policies and everything else. Yeah, so you get one last chance of making any changes. Perhaps it happens sometimes. You can even find out that maybe there's a better way of doing it, and you haven't thought about it at the start. But now that you see the code, it's obvious that you can do it in a better way. So yeah, it's just another step that in the process of releasing something. Yeah, and during the tech review, there's I think that's we didn't used to have that. We didn't have it all the time. So this is fairly new. I guess it's maybe a year and a half, probably. So we have the step where someone from the architecture team will go over the requirement, the acceptance criteria of the user stories or the change requests, and then go look at the code and see exactly how the implementation would look like. And lay it out in the user stories for the teams to be able to easily pick up and implement. Sometimes there are you take into consideration other features that we plan to implement. Sometimes user stories or new features don't just exist in isolation. Many times they intertwine with something else. So it's always good to to resolve any possible issues at this stage. So there's a lot of discussion with the product owners. Stuff like, are we planning to do it like this, or you try to find out whether it's a specific thing or it has to be more general and cater for extensions in the future.
Just to add to that point, I think you nailed it there. Is the fact that if before we had tech reviews, the teams were capable of doing what they need to do, but what that meant is lack of consistency. So every team had their own flavor. They had the ability to do things the way they understood it. And lack of consistency and lack of that holistic view across the entire stack meant that they may not have the full picture to solution something ad hoc. And that results in sometimes a lot of rework. So what came out of that was the ability to have that bottleneck where we have to sort of have a centralized place where things are assessed on a more holistic point. We use the architectural form quite a bit for that, but really it's all about understanding the end-to-end flow and having some guidance to the teams about where they should focus their effort, and be a bit more prescriptive about what needs to be done. So that was the intention, is the ability to have somebody across the whole stack, challenge the product owners, do a lot of due diligence in advance, so that when the teams pick up a piece of work, it's been fairly well analyzed and they just kind of run with it and not have to do a lot of thinking. Not that it's don't want them to think or anything, but it's more like a lot of the research time has been done in advance. So that was sort of the purpose of it.
Yeah, obviously. I mean, yeah, you don't want to have surprises. We used to have this where you picked up a user story, started implementing it, and halfway, down the road, you realized that, oops, we're missing some dependency, and you had to put that story on hold and go work on something else, to resolve that dependency. So this is the stuff that we're trying to avoid this time. And I think it's working quite well. Yeah.
It must, because I think the cadence of the teams has reached a point where clearly they're able to consume the work at a steady pace and not have to stress out. And normally the initial refinement sessions were a bit of a stressful for everyone because they had to kind of take on a piece of work they knew very little about and start dissecting it, make some assumptions, and the clock was ticking, the sprint was going. So having that little bit of analysis done in advance and somebody to shoulder tap for questions, Adrian and myself, means that they're able to get the context very quickly and they know it's been validated and they just kind of dive right into the details. So yeah.
And also I don't think it's just the development part of things that's the only thing important here. It's also the fact that the management have gone on board with this, because it is a time-consuming step of the process, but it saves us time in the long run. So everyone has to be on board. You can't have your product owners or your release manager saying, why does it take so long? We have to move faster. Everyone has to be on board and understand that it's a bit slow to start, but once we start, we take it all the way. Yeah.
So for sure, better the devil you know than the one you don't, right? But yeah, I wanted to change tack a little bit. I understand you both are big proponents of and kind of an automate everything approach to engineering and design. And I was wondering if you could shed some perspective on this and perhaps some examples of how this is manifested in your work.
Yeah, absolutely. So this all has to do with resourcing. So we don't have an infinite number of people. Automation takes time up front and it's a time saver over and over and over again. So It's an approach that we've sort of incorporated into the V2 platform from the get-go, and we never looked back. The amount of automated tests we've got is quite tremendous, to be quite honest, for the small code base and small company that we've got. So developers take it for granted, everybody does, but really, if you think about what's being done on a day-to-day basis, people write code, well, as soon as it gets merged into our master branches of the relevant services, it gets automatically built, tested, packaged, deployed, and you can see the result in under 5 minutes. So right away, you get that feedback loop, and a product owner can validate that feature straight away. A release manager knows what's coming, and then from there onward, promoting that code to our pre-production UAT environments and production environments is push of a button. So we've got single release manager that's able to completely orchestrate all the releases across all our tenants with that, I don't want to say limited technical knowledge because Mark is quite bright, but certainly with just a push of a button. So that's something that many companies aspire to do. They have the ability to have a push button release. So that in itself is quite massive. So things are generally, it's like, you know, it's well orchestrated. So at every step of the way, there's automation as much as we can. Our testing is not fully automated, so we've got we're sprinkling a bit more UI automation now. We've had some deep component testing, level test, and unit testing. Everything's automated. So every single new a new kind of change to the architecture that comes through, the first question we ask is, well, how do we make sure that this is effort-free going forward? Let's invest the time up front, but let's make sure that it sticks to our automation policy, whereby we set it and forget it, basically. So yeah, it's a big time saver. Otherwise, we'll have dozens of people continuously, handcrafting every step of the way. The other big obvious advantage to automation is removing a lot of the human error. So if you're able to script it, why not? You have less people doing it, and you have a consistent way to do it, and you're guaranteed to have error-free type of approach. So.
No. Awesome here. One thing I wanted to understand a bit more is I understand that Nicefolks is a fairly small organization, kind of by normal standards, and I understand we don't use kind of pre-built frameworks as kind of a rule of thumb in terms of building things out. And I was wondering why the thinking around that and why that is, because that's not the norm as I understand it.
Depends on the language, ready. So by choosing to use Go, you automatically make that decision. So it's been made for you. So Go language is, I mentioned, very lean. There's not a lot of frameworks that come on top of it. Certainly there are a few popular ones, but ultimately all the tools that you need to write robust applications are already built into the language. It's available at your disposal. Any other language I've used, you do need to bring, in most cases, some libraries or frameworks able to kind of augment that functionality and give you some basic building blocks that you need to write, a proper standalone microservice or something similar. Even the web server functionality is built into the language. Almost everything you need, from concurrency or proxies and you name it. So in doing so, our code base is very kind of consistent across service to service. It's much easier to rate, and we don't rely on any third parties. And in doing so, we don't have any worries about version, mismatches and dependency hell and things like that. So everything's quite flat. Everything we write is in-house. It's built, it's bare bones, and in doing so, builds faster and runs faster.
Yeah, and I mean, in the end, it's a microservice, right? So it's supposed to be as simple as possible. If you start adding frameworks to it, then you make it more complicated.
Yeah.
The simpler it is, the better.
That's it.
Yeah.
No, that makes sense. That makes a lot of sense. I just wanted to kind of close off the conversation with one final thing, just around one thing that you'd like someone listening to this conversation to take away, kind of from your experience working Nicefolks, and I suppose kind of your experience further back afield as well. If you could tell yourself 5 years in the past, one piece of advice or piece of wisdom, what would that be?
That's a tough one, but in my opinion, I think change, it's all revolves around change. So the adopting change is not a bad thing. Technology is constantly moving. If you really are in the technology field, you have to embrace change. Things are continuously changing. Paradigms come and go. Don't be afraid of failure. We work really hard to kind of nurture a fail-fast environment. So everybody's allowed to make mistakes. We make mistakes all the time, and by having all the support needed, we can recover from failure quite quickly. And in doing so, we experiment a lot faster. We were able to get features out the door quite faster. People feel more confident, less stressed about potential failure, and in doing so, become much more forthcoming. So they propose really good ideas continuously, the engineers. So there's a lot of creativity, a lot of forward thinking, less boxing, so to say. But all that ties back to adopting change, accepting change, and continuously doing course correction. So as we learn new things, we sort of backfill that into our environment, and it creates for a really good working environment. So change is not bad.
Yeah, I agree. I totally agree with that. I think change is the only constant at Nice Folks. It's been just embrace it, and I guess don't get too attached to your code. We did have in the past, we did have solutions that were quite hard to abandon because of the emotions that were invested in it. I guess in the IT world, stuff changes, right? So
Yeah.
you just have to go with the flow, and in the end, it's what's better for all of us. It doesn't really matter whether I mean it's not personal that your your baby, the stuff that you've been working on for a year, now needs to be replaced with something else. It's just the way things go.
Great.
Yeah.
No, well, thank you guys so much for taking the time and chatting about kind of the wide world that Nice Folks plays in from an engineering perspective. So yeah, that ends us, and I just like to thank everyone listening in for taking the time to listen to this conversation. And if you are interested in learning more, feel free to look at the description of wherever you're listening to this too. And on that note, thank you.
Thank you, Eddie.
Thank you.